November 2019, paper 2, variant 3. Measuring the thickness of the coin would need a micrometer screw gauge, which has been removed from the syllabus. Question 1 is cancelled. Question 2, at which labeled time is the object decelerating? Deceleration would mean that the speed is decreasing at d. Car travels at an average speed of 60 kilometers for 15 minutes. How far does the car travel? So we need the distance equals speed times time. But the time is in minutes. You need to convert these minutes into seconds by dividing by 60. 15 divided by 60 is 0.25. So 60 times 0.25 would give you a distance of 15 kilometers. Which equation shows the relationship between weight and the mass of an object? Weight and mass. W equals mg. Box of mass, 2 kilograms is pulled across a horizontal force, 6 newtons. The friction force is 1 newtons. What is the acceleration of the box? First of all, you need to find the resultant force. The resultant force is now 6 minus 1, which is 5. 6 minus 1, which is 5. So F equals ma. To find the acceleration, it would be F over m. Resultant force is 5 over the mass, which is 2, which is 2.5 meters per second squared. 4 hollow glass spheres have a mass of 62 grams. Their volumes are given. Which spheres sink in a liquid of density 0.9? Sink, right? Which of these can sink? First of all, you need to find the densities. We need to find the density. Which of these densities would be larger than 0.9, right? So density equals mass over volume, 72 over 55. What's 72 divided by 55? This is 1.3. This would definitely sink. 1.3. Again, 72 divided by 65, 1.1, right? Divided by 65, this is 1.1. 72 divided by 75, this is 0.96. Okay, it would also sink. And the last one, 72 divided by 85, 0.84, 0.84, 0.85. It will not sink. So only PQ and R. Diagram shows a uniform meter ruler. The ruler is pivoted at midpoint. Downward force 4 newtons is at the 5 centimeter mark. What is the upward force that is exerted on the string? What is the upward force? So force times distance, you have only 2 forces acting, right? You have only 2 forces acting. 4 times the distance to the pivot. What's the distance to the pivot? It is 45 centimeters, right? Equals force times distance. What is this distance? It's 20. 4 times 45, it's 180. 5 times 20 divided by 20. This is 9 newtons. A ship sails due north at a speed of 20 meters per second. The current begins to move from the east to the west. From the east to the west. The speed of this current is 20 meters per second. What is the magnitude of the resultant velocity? Can I solve this question? Yes. If the ship is moving north 20 meters per second, 20 meters per second, and then there is a current moving from east to west at a velocity of 20 meters per second. Can I find the resultant force or the resultant velocity? Yes. Square root 20 squared plus 20 squared using Pythagorean theorem. What is square root of 20 squared plus 20 squared? This would be 28 meters per second. The momentum of a body is changed by a force acting on it for a period of time. Which action increases the change in momentum? How can I increase the change in momentum? Doubling the force and halving the time. This would be the same momentum. Doubling the force for the same time. Yes, for some time you need to double the force and leave the time as this. A toy train E of mass 0.5 kilograms, traveling along a straight track with a velocity of 3 meters per second, collides with a stationary train Q of mass 1 kilograms. The two trains stick together. What is the velocity of the combined trains? So, M1 U1 plus M2 U2 would be equal to what? MV, in which M is equal to M1 plus M2. M2 U2 is 0 because the other train is stationary. M1 U1 would be 0.5 times 3, which is equal to the combined masses of these two trains is 1.5 times the velocity. 1.5 would be equal to 1.5 v. To find the velocity, it would be equal to 1 divided by 1.5. Okay, so the speed or the velocity would be 1 meters per second in the same direction. If you have two objects, one object station, the other object is traveling in some direction, a certain direction, it would collide with the object and they would both move in the same direction. Brakes are used. In which form of energy is most of the kinetic energy converted as it slows down? Definitely thermal energy. A force acts on an object. The work done by the force is 400 joules. How far does the object move? We know that work done equals force times distance. Can I find the distance? Yes, work done over force, which is 25 newtons. I'm sorry, 400 newtons. 400 joules. Somehow I keep on forgetting joules. 400 joules divided by 25 newtons. Yes, this would be 16 meters, not centimeters. Please do not make this fatal mistake. 16 meters. Okay. A car is moving along a straight horizontal road. The car has 1.6 mj. What is mj? Megajoules. The car accelerates for 20 seconds until the kinetic energy is 2.5 megajoules. What is the minimum average power? Minimum average power developed by the car. What is power? It is energy over time. It is energy over time. Can I find the change in energy? Yes, I can find the change in energy, which is 2.5 minus 1.6. This would be 0.9 megajoules. You can multiply it by 10 to the power of 6, right? Multiplied by, which is 900,000 joules. Divided by 20 to find the power. If you divide 900,000 divided by 20, what's 900,000 divided by 20? This is 45,000 joules. 45,000 joules, or you can say 45 kilowatts. Instead of saying 45,000 watts, you can just write down 45 kilowatts. Drawing pin has a sharp point at one end and a flat surface on the other end. How do the pressure and the force compare? The force at the sharp point, would it be greater? No, actually it would be the same. Why would it be the same? Why would it be the same? Because it's the same object. You have the same force being applied. But the pressure differs. Why does the pressure differ? Because of the surface area. So the pressure would be greater than that of the surface area. Why? Because of the area. As you decrease the area, the pressure increases. Okay. Cool liquid. Yes, which row compares the separation, the motion of the molecules in hot gas with those in cool liquid? The separation in hot gas. What happens in the hot gas? The separation is greater. What about the motion? It is also faster in the gas. Fixed mass of gas has a volume of 25 centimeters cubed. Pressure is 100 kilopascals. The volume decreases by 15 centimeters cubed at a constant temperature. What is the change in pressure? What is the change in pressure? Again, think about it or read the question carefully, please. The volume is decreased by 15 centimeters cubed. So the final volume is what? Initial volume was 25. The final volume is now 10 centimeters cubed. Why? Because it decreases by 15 centimeters cubed. Now I can use the equation P1 V1 equals P2 V2, right? P2 V2. The pressure of the gas is 100 kilopascals. So 100 kilopascals, okay, multiplied by the volume. The volume is slowly decreased by 15. So the pressure, can I find the P2? Yes. V2, what is V2? It's now 10 multiplied by 10. So if you solve for this, the pressure would be 250,000 pascals or 250 kilopascals. A lot of you might say it's D, which is wrong. Why? Because this is the final pressure. The question is asking you to find the change in pressure. To find the change in pressure. So the initial pressure was 100 kilopascals. The final pressure, which was 250. So 250 minus 100 is 150 kilopascals. This is the change in the pressure. Okay? Please take care while reading these questions. Liquid turns into gas, occurs at a particular temperature. What is this process called? It's called boiling. Question 18 is cancelled. Question 19. A sealed metal box contains fixed mass of air. The sides of the box are insulated. A scientist investigates the thermal conductivity of air. Thermal conductivity of air. She measures how quickly thermal energy passes between the top and the bottom of the box. Again, what is she measuring? The thermal conductivity of air. Which row gives the correct procedure and the conclusion? So should she heat the bottom surface or the top surface? A lot of you might say, well, she should heat the bottom surface. That's what we are used to doing, right? We are used to heating the bottom of any surface to heat it up quite quickly, which is in this question it would be wrong. Why would it be wrong? So heating the bottom surface would be wrong. Why? Because you need to test the conductivity. If you heat the bottom surface, the air would heat up quite quickly due to convection, not due to conduction. The air would heat up quickly due to convection. That's why if you want to test the conduction of air, you shouldn't heat it up from the bottom surface. You should heat it up from the top surface. Okay? Why? Because you'd find that the air would heat up quite slowly. Why? Because the air is a poor conductor. The air is a poor conductor of heat if you start to heat it up from the top surface. In a cold country, the ground is covered in snow. There is a pile of black sand outdoors, and its temperature is the same as that of the snow. A man sprinkles a thin layer of this sand over the snow. Why does the black sand help to melt the snow during the day? Black sand. What does the black sand do? It is a good absorber. Yes. And any thermal energy left in the sand will now melt in the snow? No. The black sand is a good absorber of the infrared radiation. Yes. That's why the snow melts quickly. Question 21. A transmitter and a receiver. The transmitter picks up the signal, okay, from the receiver picks up the transmitter even though the radio waves do not travel through the hill. They do not travel through the hill. So how do they travel? They actually travel around the hill, right? Around the hill. Which row is correct? A possible way for this happen. How can they travel around the hill? Again, around the hill. Can they refract around the hill? No. Refraction means that they have to go through the hill, change the medium, and then be refracted. They actually diffract around the hill. It's as if it's a gap, and they're bending or they're spreading. Not bending, they are spreading after passing through this gap. A stronger signal is received using what? Using longer or shorter wavelengths. Again, this is diffraction. So if I have diffraction, if I need to increase the diffraction, I need to use longer wavelengths. If you increase the wavelength, you increase the diffraction as well. Person stands 1 meter in front of a plane mirror. The mirror is moved away from the person at a speed of 1 meters per second. Which statement is correct? Which statement is correct? As the mirror is moving 1 meters away, 1 meter per second away from the person, then the image is moving. Is it moving towards the person? When the mirror is moving away, then the image would also move away. So C and D are wrong. So is the image moving at the speed of 1 meter per second or 2 meters per second? Actually, it's moving at a speed of 2 meters per second. Why? Why is it moving at a speed of 2 meters per second? Because if you think of this is the mirror, this is the object, and this is the image. The distance between the object and the image, let's say that the distance is 10 centimeters, right? And distance is 10 centimeters. So what is the total distance? So you need to multiply the distance. It's the total distance between the object and the image is what? It's actually 20 centimeters. So if the image moves away, let's say that the image is now 20 centimeters away, then the object will also be 20 centimeters away. So the total distance is what? Is 40 centimeters away. Basically, you're multiplying by 2. You are multiplying by 2. The speed increases, yes, but the speed would increase between the object and the image by a factor of 2. You need to multiply by 2. Okay. White light is refracted and dispersed when it enters a glass prism. Which color has the lowest speed as it moves through the glass prism? The lowest speed would be the highest refraction or the violet light. These waves are in the order of increasing what? Increasing from gamma rays to radio waves. So you have increasing wavelength. Increasing wavelength. Which row gives a possible set of values for the speed of sound in ice, water, and steam? In ice, it would be the highest speed, right? It would be the highest speed. Why? Because this is a solid. In the steam, it would be the lowest speed of 500. So we might say it's D, right? Question 26 is cancelled. Demagnetization has been removed from the syllabus. Plastic rod is rubbed with a dry cloth. The rod becomes positively charged. Why does the rod become positively charged? Because of losing electrons. There is a current of 3 amperes in a resistor for a time t. During the time t, a charge of 120 coulombs flow through the resistor, right? What is time t? What is time t? Can I find t? Yes. What is the equation we use? I equals q over t to find t to be q over I. 120 divided by 3, which is 40 seconds, not minutes. 40 seconds. What is the correct order of resistance from the largest to the smallest? Largest resistance. If I have resistors in series, then the resistance increases. This is the largest resistance. If you have resistors in parallel, then this would be the least resistance. So from largest to smallest, it would be Z, Y, X. Question 30. Resistors of resistance 1, 2, and 3 are connected in parallel. Which statement is correct? The currents in the resistors are equal. Can they be equal if they are in parallel? No, they cannot be equal. The sum of the currents in the 3 resistors is equal to the current in the cell. Yes, this is correct. Because they are in parallel, right? The sum of the potential difference, no, this is wrong. Because they all have the same potential difference, right? Question 31. What is component X? So we have a component X. This is an AC power supply. And the resistance or the voltage, the potential difference in the resistor looks somewhat like this. So what's component X? Component X has to be a diode. Why? Because in this part, diode prevents the current from passing in the opposite direction. 32 is cancelled. 33. Where must the fuse be connected in the mains electric circuit? It has to be connected in the on the live wire. right, on the live wire. A wire XY is connected to a resistor R. Okay, the wire is moved. The wire is moved, and the magnetic field between them. The wire is moved. So this is electromagnetic induction, right? So that there is an induced current. You have to use Fleming's right hand rule, right? Fleming's right hand rule. So north to south, you have first finger pointing to the left. And then the current is into the page. Therefore, the force, the motion would be downwards. The motion, your thumb should be pointing downwards at B. Okay? Okay, 35. A step-up transformer produces 60 volts, okay, of output from a 12-volt input. There are 50 turns on the secondary coil. Vp over Np equals Vs over Ns. Vp, the primary voltage input, what was 12? It was 12. Divide over Np, do not know Np. Vs was 60, and Ns was 50 turns. Cross multiplication, this will give you an Np of 10. An AC generator contains a coil that rotates at a rate of 4,500 revolutions per minute. What is the frequency of the alternating current? Can I find the frequency? Yes. Frequency would be basically the number of revolutions per minute. 4,500. Frequency is the number of waves per second, right? Per second. So 4,500 divided by what? Divide by 60, because you have to divide by the amount of time in seconds, which will give you a frequency of 75 hertz. Why are some radioactive sources stored in boxes made of lead? Lead absorbs emissions from the radioactive sources. Yes, this is correct. Lead decreases the half-life. No. Increases the half-life. Repels. No, it doesn't repel. It absorbs the emissions. This is a neutral atom. Which row identifies each type of particle in the diagram? If it's a neutral atom and you have 2 electrons, then you have to have 2 protons. This has to be a proton. This is a proton and this is an electron. Therefore, this must be a neutron. Okay, neutron. A thin metal foil is placed in a vacuum. Alpha particles are fired at the foil. Most go straight through. A very small proportion of the alpha particles are deflected through large angles. Why does this? What does this provide evidence for? Alpha particles are very small. I don't care about the alpha particles. There are negative electrons in each atom. There are negative electrons at. No, this is wrong. Okay, this isn't proof. Alpha particles are deflected through large angles. There is a tiny nucleus in each atom. Yes, this is what we figured out. We figured out that this tiny nucleus deflects some of these alpha particles back. Okay, some of these alpha particles are deflected back due to the mass of this nucleus. Background radiation is counted 40 counts per minute. With the counter close to the radioactive source, it's 960 counts per minute. The half-life is 20 minutes. What is the counter reading 1 hour later? Counter reading 1 hour later. So if you have a counter reading and you have a background radiation, you need to minus, divide, and then plus. Minus, divide, and plus. 960 minus what? Minus 40, which is 920. We need to divide 920 by how many times? But we need to divide by 2. How many times? In 1 hour, how many 20 minutes do you have in 1 hour? 60 minutes divided by 20 is 3 half-lives. So you'll divide by 2 3 times. 920 divided by 2 is 460. 920 divided by 2, okay, is 460. Right? Divide by 2 again, 230, right? And then divide by 2 again, it is 115. Again, 115 is the source. You do not need the source. You need the total reading. You need the total reading on the counter. So plus again, so 115 plus 40, which would be 155 counts per minute. Okay?